This episode is sponsored by Audible, which honestly feels extremely on brand for a show that loves a good deep dive. Audible is where I go when I want to feel productive while doing absolutely nothing with my eyes. Audiobooks, podcasts, Audible originals. It's perfect for cleaning, driving, walking the dog, or lying on the couch pretending you're having a thoughtful moment. If you're into pop culture, true crime, conspiracies, memoirs, or those books everyone keeps telling you have to read, it's all there. Audible lets you listen your way whenever you want. And it's one of those things that very quickly becomes part of your routine. Trust me. You can check it out at the link in the show notes or on our website at whynotpod.com/sponsors. And heads up, they often run really good limited time offers for new members. So if you've been thinking about trying Audible, this is your sign. So give Audible a try, because why not? Do you ever think about how we all watched Jurassic Park and collectively agreed, yeah, that was a terrible idea, and then just kept going anyway? Like, as kids, we're like, oh my God, dinosaurs, this is amazing. And now as adults, you rewatch it and you're like, wait, this is just a bunch of people with money and technology making deeply questionable decisions with absolutely no plan for what happens next. And somehow that didn't scare us enough. Because here's the thing, and I need you to sit with this for a second. There are scientists right now actively working on bringing extinct animals back to life. Not in a maybe someday in the distant future kind of way, like currently as we speak. So the question is no longer, could Jurassic Park happen? Now it's, what version of it are we already building? Welcome back to Why Not Talk About It, the podcast where we unpack the world's most chaotic stories, mysteries, cults, conspiracies, crimes, and cultural moments, one glass at a time. And today's episode feels like science, but also a warning label, because we're talking about de-extinction, what it is, how it works, the companies that are actually doing this, and how close we really are to something that starts to look a little too much like Jurassic Park for comfort. We're also getting into what animals are on the table, because it's not just mammoths, by the way, whether dinosaurs are even remotely possible, and the part where this all starts to get a little ethically questionable. But don't worry, we're keeping it fun. I've got some questions. Because listen, we're a lot closer to this being real than I think most people realize. So let's get into it. All right, so before we even get into the science of all of this, we need to talk about Jurassic Park for a second. Because I genuinely think we all watched that movie and focused on the completely wrong thing. Like, yes, dinosaurs, very cool. Groundbreaking visuals, iconic scenes, childhood core memory. We love her, right? But the actual point of that movie had nothing to do with dinosaurs being cool. It was about humans doing something just because they can, and not stopping for even 1 second to ask if they should. And the wild part is, they literally spell this out for us in the movie. You've got John Hammond, who's basically like, we spared no expense, which sounds great until you realize that what he really means is, we threw money at something insanely complex and assumed that would make it controllable, right? And then you have Dr. Ian Malcolm, Chaos Theory King, who's essentially sitting there the entire time like, hey, this feels like a terrible idea. Then there's that famous line, paraphrasing, of course, but it's basically, you were so preoccupied with whether or not you could, you didn't stop to think if you should. And I'm sorry, that is the entire episode right there. Because when you strip away the dinosaurs, what you're left with is scientists pushing boundaries, investors funding big, flashy ideas, a belief that we can control nature, and a lot of confidence with not a lot of long-term planning. Sound familiar? Because that doesn't feel like a fictional storyline. That feels like a business model. And I think that's what's so interesting about revisiting this as an adult. As a kid, it feels like an adventure. As an adult, it feels like a cautionary tale that we maybe didn't take seriously enough. Like, the movie wasn't saying, look how amazing this is. It was saying, look how quickly things can go wrong. And yet, here we are. We're still asking the same question. What can we do next? Instead of, should we be doing this at all? So, now that we've established that we may have collectively missed the point, let's talk about what we're actually doing in real life. Because this is where it starts to get a little too real. So let's talk about what de-extinction actually is, because it sounds like something straight out of a sci-fi movie, but it's very much not. At its core, de-extinction is exactly what it sounds like. The idea of bringing extinct species back to life. Simple, casual, totally normal thing for humans to be working on. Except when you look a little bit closer, it's not quite as straightforward as, we found some old DNA, let's just bring it back. Because in reality, we're not reviving extinct animals. We're more so recreating them or approximating them or honestly just kind of like remixing them. And there are a few different ways scientists are trying to do this. So there are 3 different methods, and method number 1 is cloning. This is the one most people usually think of first. So basically, you take DNA from an extinct animal, insert it into an egg cell, and try to grow a new organism from it. This is how we got Dolly the sheep back in the 90s, which was a whole ass moment. But here's the issue. Cloning only works if you have really well preserved DNA. And the thing with DNA is it's not built to last forever. It starts breaking down pretty quickly after death, and over time it basically just disintegrates. So unless something has been frozen or preserved in very specific conditions, cloning becomes almost impossible, which is why this method doesn't really work for things that went extinct a long, long time ago, like millions of years ago. All right, so now we are moving on to method number 2, which is genetic engineering. This is where things start to feel a little futuristic. So CRISPR, C-R-I-S-P-R, which is an acronym for Clustered Regularly Interspaced Short Palindromic Repeats, I prefer the acronym personally, is a tool that allows scientists to edit DNA, like literally go in and cut, remove, or insert specific genes. So instead of cloning an extinct animal, the idea is you take a living species that's closely related, edit its DNA, and add traits from the extinct species. So you're not bringing something back exactly as it was, you're pretty much creating something that resembles it, which is where we get into this very weird gray area of like, what even counts as the same animal anymore? Because if you take an elephant and then start editing its genes to make it look more like a mammoth, is that a mammoth or is that just a very old elephant? I mean, you know what I mean? Okay, so then lastly, we have method number 3, which is back breeding. This one is a little less high tech, but still kind of wild. Back breeding is basically taking animals that share traits with an extinct species and selectively breeding them over generations to bring those traits back out. So instead of editing DNA directly, you're kind of encouraging evolution to go backwards a little bit, which sounds simple, but it takes a long time and doesn't really guarantee exact results. And this is where we need to pause for just a second, because all of this sounds like we're bringing things, back from the dead, but we're really not. Like I said, we're creating versions of them, approximations, interpretations, which honestly feels like a very on-brand human move. Like, we're not just bringing back extinct species, we're redesigning them. And I don't know, that just feels like a slightly different level of responsibility because now it's not just we brought this back, it's, we decided what this should be. So already we're off to a very normal and not at all concerning start. And this is just the foundation. Because once you understand how this works, you start to realize, oh, we're not that far off from actually doing it. Which leads us into the part where things get a little bit more like, wait, excuse me? Okay, so now that we've covered how this works, let's talk about the part that made me personally stop and think, like, when did this become a thing? Because this isn't theoretical. This isn't like maybe one day. It's already happening. It's in labs right now, quietly, casually, just like it's another Tuesday. And the more you look into it, the more it starts to feel like we skipped a few steps as a society. So let's just go through a few things that are currently happening, and you can decide how you feel about it. Scientists have already taken DNA from woolly mammoths, like I mentioned earlier, actual frozen remains, and started inserting specific mammoth genes into elephant DNA. Like, not hypothetically. They've already edited genes related to hair growth, fat storage, and cold resistance. So basically, we're actively building the blueprint for a cold-adapted mammoth-like animal. And I'm sorry, but the fact that this sentence exists in real life feels insane. There have also been cases where scientists were able to bring back certain biological functions in extinct species, but just temporarily. One of the most well known examples is the gastric brooding frog. That's a name. This frog had a very bizarre trait. It would swallow its eggs, incubate them in its stomach, and then basically give birth through its mouth. Nature is wild. That's disgusting. But scientists were able to take preserved tissue from this extinct frog and partially revive cell activity using clone techniques. It didn't survive long, but the fact that it happened at all is unsettling. Like, we're just casually testing the boundaries of life and death now. And then there's CRISPR, that acronym we talked about, which I know we had mentioned it already, but I need you to fully grasp what this means. This is a tool that allows scientists to cut DNA, remove pieces, insert new genetic material, and rewrite an organism's genetic code. Like editing a document. You know what I mean? You can open it up, tweak a few things, save it, and now it's something different. And we're doing that with living things, which is incredible and also terrifying if you think about it for more than 5 seconds. There have been discussions and early stage experiments around something called de-extinction proxies, which is basically science's way of saying we're not bringing the original animal back. We're recreating something close enough that it functions the same way. Close enough? I'm sorry. Since when is close enough the standard for recreating extinct species? And I think what makes all of this feel extra surreal is how normalized it's starting to sound. Like, you read about it and it's framed as innovation, conservation, scientific progress. And to be fair, some of it is. Definitely some of it is. And we'll talk a little bit about that later. But at the same time, I can't help but feel like we're slowly inching into territory where we're doing things not because we fully understand the consequences, but because we're curious. And curiosity is great until it's not. So yeah, this is not some distant future situation. This is happening. The tools exist, the experiments are happening, and the momentum is building. And now that we've established that we're already in it, let's talk about the people behind it. Because this next part feels a little less like science and a little bit more like a startup pitch. All right, so now that we've established this isn't just theory, let's talk about who is actually doing this. Because this isn't just happening in, quiet little university labs somewhere. These are like full-on companies, funded, staffed, and very public, working on de-extinction projects right now. And one of the most well-known is a company called Colossal Biosciences. Now, to be clear, everything I'm about to talk about here is based on publicly available information, their stated goals and what they've shared about their work. So don't come at me, Colossal Biosciences. But when you look at it from the outside, it does start to feel a little bit like science meets startup culture. Colossal Biosciences was founded in 2021, and their entire mission is centered around de-extinction and what they describe as genetic rescue. So not just bringing species back, but also using this technology to help preserve or strengthen currently endangered ones, which on paper sounds amazing. Like, if we can use science to repair ecosystems or prevent extinctions, that's incredible. No notes, right? But then you look at what they're actually working on and it gets a little bit more Jurassic adjacent. Their main projects include the woolly mammoth, as we've discussed, the Tasmanian tiger, and the dodo bird. I mean, I wouldn't be upset if a little dodo bird came back, but anyway. But their approach is exactly what we talked about earlier, using genetic engineering to create modern animals that carry traits of these extinct species. So again, not exact replicas, obviously, but close enough to function in similar ways. They've also raised a significant amount of funding and have backing from major investors, including people from the tech world, which makes sense because this kind of work is expensive, complex, and very cutting edge. But it also means that this isn't just a slow academic process. There's momentum, there are timelines, and there are definitely deliverables. And according to their own projections, some of these animals, or versions of them, could exist within the next several years. Not centuries, not one day, like a few years from now. I mean, this is escalating quickly, if you ask me. Now, again, to be fair, their stated purpose is largely focused on conservation. They've talked about things like restoring ecosystems, reintroducing lost biodiversity, and helping combat climate-related changes. So this isn't being presented as let's build a theme park. It's being framed as we're using advanced science to fix environmental problems. But I do think there's a question here that feels very valid. Like, shouldn't we also be asking what happens when you reintroduce something into an ecosystem that has already evolved without it? Because nature has been doing its thing this whole time, adapting, shifting, rebalancing. So if we come in now and say, okay, let's add this species back in, what does that actually do long term? Does it help? Does it disrupt something else? Does it create new problems that we didn't anticipate? My vote's on that one. And I'm not saying there's a clear answer, but it's one of those things where it's like we're not just bringing something back into the world, we're inserting it into a version of the world that no longer looks like the one that it came from. And that feels like a very different conversation. Because when you combine cutting edge genetic technology, major funding, big ambitious goals, and relatively fast timelines, it starts to feel less like a slow scientific exploration and more like something that's being actively built toward. And that's not necessarily a bad thing, but it is something to pay attention to. Because historically, when humans get excited about what's possible, we tend to move a little faster than we fully understand and, get ahead of ourselves. And again, this doesn't mean anything nefarious is happening. It just means this is real, it's organized, and it is moving forward. All right, so let's talk about the woolly mammoth for a little bit here, because this is basically the flagship project of de-extinction right now. And they have been working on this for, a number of years at this point. I mean, I don't think a decade, but, whatever. So if this were a startup, which again, it kind of feels like, it's the product they're leading with, and on the surface, it almost makes sense. Mammoths went extinct relatively recently, around 4,000 years ago, which in evolutionary terms is like basically yesterday. So, unlike dinosaurs, we actually have access to pretty well preserved mammoth remains. We're talking, frozen carcasses found in permafrost, hair, tissue, even traces of blood in some cases. Basically, enough genetic material to piece together large portions of their DNA, which is why scientists are like, okay, this is actually doable. But here's where things start to get a little fuzzy, pun intended, because they're not actually bringing back a woolly mammoth. They're taking an Asian elephant, which is the mammoth's closest living relative, and editing its DNA to include specific mammoth traits. So things like, thick, shaggy hair, increased fat layers, cold resistant blood adaptations. Basically, they're trying to engineer an elephant that can survive in Arctic conditions. Why? Like, you're just going to create it and throw it in Antarctica? Whatever. So basically, what you end up with is not a mammoth, it's a genetically modified elephant that resembles a mammoth, right? Which again raises that question, what are we actually creating here? Because it's not a resurrection. It's, again, more like a recreation, or honestly, a rebrand, maybe. I don't know. And the reasoning behind this is actually really interesting. The idea is that reintroducing mammoth like animals into the Arctic could help restore what's called the mammoth steppe, a type of grassland ecosystem that existed during the Ice Age. So, okay, like that makes sense, I guess. But anyway, so the theory is that these animals would knock down trees, compact snow, promote grass growth, and that this could potentially help slow permafrost thawing and reducing carbon release. So again, on paper, very cool, very science, very, we're saving the planet. But then you zoom out a little and it's like, okay, but we're still creating a brand new version of an animal and placing it into a modern ecosystem that has been functioning without it for thousands of years. And we're assuming we understand how that's going to play out. There's also the timeline piece, because some of these companies have suggested that we could see these mammoth-like animals within the next decade, which is not far away. Like, that's not a distant future concept. That's, this could be happening while we're still alive and complaining about gas prices. And then there's the part that I personally cannot stop thinking about, that these animals wouldn't have the same social structures, environments, or evolutionary context they originally had. So even if you successfully create something that looks like a mammoth, what kind of life does it actually have? Where does it go? Who's taking care of it? Is it wild? Is it managed? Is it experimental? And I don't know. There's just something about the idea of engineering a prehistoric inspired animal and placing it into today's world that feels a little like we're testing something we don't fully understand yet, which again, very on brand for us as a species. So yeah, the mammoth isn't just a cool science project. It's kind of the proof of concept. Like if this works, it opens the door to everything else. And that's where things start to get really interesting because the mammoth is just the beginning. So there's kind of a wish list happening here, if you will. And the more you look into it, the more you realize people are not thinking small with this at all. So let's just go through a few of the animals that are either already being worked on or are very much on the radar, because some of these choices are interesting, to say the least. All right, so first up, we have the dodo bird, which honestly feels a little unfair because humans are the reason this bird went extinct in the first place. So now there's this argument of like, well, we should bring it back, right? Which, okay, I get that. But also, this was a flightless bird that evolved into a very specific environment with no natural predators. So if we bring it back, where is it going? Because we are the predator, right? All right, next up we have the Tasmanian tiger. And this one is actually one of the more realistic candidates. It only went extinct in the early 1900s, so the DNA situation is much better. And there are already active efforts to try and recreate it, which on one hand is fascinating, but on the other hand, it's like we couldn't keep it alive the first time, so what exactly are we doing differently now, right? All right, next up we have the passenger pigeon. This one blew my mind a little bit. There used to be billions with a B of passenger pigeons in North America, like flocks so large they would literally darken the sky. And now, completely gone. So the idea here is to bring them back to help restore ecosystems, which sounds great until you realize that the ecosystem they existed in doesn't really exist in the same way anymore. All right, now we have the giant ground sloth. Okay, so this one feels like we're getting a little bold. You know what I mean? These were massive prehistoric sloths. Not like the cute little sloths you see hanging from tree limbs or whatever. Like several feet tall, extremely powerful, roaming around North and South America thousands of years ago. And the idea of just casually reintroducing something like that into the modern world that's a choice. You know what I mean? All right. Finally, we have the woolly rhinoceros, basically the mammoth's equally intimidating cousin, another ice age giant. Same general idea here. So cold adapted, potential ecosystem impact, just a very large, very real animal. And again, it's like, okay, where is that going? Where are we putting that? So now let's just have a moment for the dinosaur conversation because I know y'all have been waiting for it, but no, we are not bringing back a T-Rex, right? That's just completely ridiculous. That's a death sentence. So let's all just take a breath. Scientifically, that's not really possible for a bunch of reasons that we'll get into. But that hasn't stopped people from asking, if we could, what would that even look like? The dangerous question. So if you were to even entertain the idea, purely hypothetically, you're not starting with a T-Rex. You'd be looking at smaller, more manageable species. Things like velociraptor type dinosaurs. So, smaller, faster, highly intelligent, which honestly feels worse in some ways. Something called, I think I'm saying this right, Compsognathus. I don't know, probably not. But they're basically those tiny little ones from Jurassic Park, just small bird-like pack behavior, just chaotic little gremlins, pretty much. Then you've got triceratop type herbivores. So larger, obviously not predators. I mean, herbivores means they're not going to be eating humans, but still massive and still could absolutely take you out if they felt like it. And then lastly, pterosaur type creatures. So just flying reptiles, which I'm sorry, why are we even entertaining flying prehistoric animals? And again, this is not something that's actually happening. But when you look at the direction science is moving, editing traits, recreating features, working from living descendants, it's not crazy to think that we would end up with something that resembles these creatures in certain ways. And then on top of that, we have the dino-chicken situation. Yes, I said that, dino-chicken. Scientists have actually explored the idea of taking bird DNA, because birds are the closest living relatives to dinosaurs, and reactivating dormant traits. So, things like giving chickens teeth, extending their nails, modifying their limbs to be more claw like. I'm sorry, a dinosaur chicken? What will we think of next? Okay, so again, we're not building a T-Rex. We can all just relax. But it is the idea of reverse engineering certain dinosaur traits into modern animals, which feels like we're getting creatively ambitious. And if dinosaurs were somehow possible, which scientifically is a whole different conversation, we're not talking about massive movie style predators right out the gate. It would likely be, smaller species, simple organisms, something much more controlled. But still, even that feels like a line where it's like, why are we even inching in that direction at all? Because once you start listing all of these out together, mammoths, tigers, dodos, giant sloths, rhino type situations, and dino chickens, it stops feeling like individual science projects and it starts feeling like we're slowly rebuilding a version of the past. And that's the moment where, for me at least, the question shifts because it's no longer just, can we bring something back? It becomes, where exactly is all of this supposed to go? So let's talk about that because this next part might actually be the most important question of the entire episode. All right, we need to talk about something that I feel like is not being discussed nearly enough. Where the hell are we putting these things? Like, genuinely, where are they supposed to live? Because it's one thing to bring something back, it's another thing entirely to figure out where it fits in a world that has completely moved on without it. And that's the part that feels a little, overlooked. At least to me. Maybe they've done some extensive research on this that I don't know about. That's possible. But ecosystems are not static. They've been evolving, adapting, and rebalancing for thousands, sometimes millions of years since these animals existed. Climate has changed, landscapes have changed, food sources have changed. And most importantly, we have changed everything. We've built cities, highways, neighborhoods, entire infrastructures that did not exist when these animals were around. So it's not like we're bringing them back into the same world that they left. We're dropping them into something completely different. And this is where I need to say this. These certainly will not be cute little land before time baby dinosaurs. These things are ginormous, lethal, and not made for our current world. Like, they're not cartoon characters. These are real animals with real instincts that evolved for environments that do not exist anymore. So, what are the options here? Because none of them feel super simple. Are they going to live in protected, reserves? Okay, where? How big are these areas? Who's managing them, if anyone? Uh, what happens if something escapes? And are they going to be kept in controlled environments? Because then we're kind of entering this weird gray area of like, is this conservation or is this just a very high tech exhibit? Are they wild? Because that feels bold, right? We already struggle with managing wildlife that currently exists: deers, coyotes, bears. Like, we have an entire, we have entire systems in place just to try and keep things balanced. And even then, it's not perfect. So now we're adding in animals that haven't existed for thousands of years, don't have a natural place in modern ecosystems, and may behave in ways that we don't fully understand yet. And then there's the ripple effect, because it's not just about that animal, it's about everything it interacts with. What does it eat? What eats it? What does it displace? And what does it actually destroy? Because ecosystems are just basically like a giant web. You pull one thread and you don't always know what else is going to move. And I think that's the part that makes this feel like, less of a science project and more like a very complex real world experiment. Because it's not just, can we bring this back? It's, where does it belong now? And if the honest answer is, we don't really know yet, then that raises a whole new set of questions. So now that we've gone from this is cool to this is fucking complicated, let's take a quick step back and talk about something that honestly surprised me when I first learned it. Because if we're talking about dinosaurs, there's one detail that feels completely backwards. Let's talk about why birds are actually the closest thing we have to dinosaurs. I mean, how crazy is that, right? It's not reptiles, not crocodiles, not lizards, birds, like pigeons or, you got it, chickens. And I know it, it feels illegal because when you think dinosaur, your brain goes, scales, teeth, giant lizard energy, not feathers, not wings. But evolution said otherwise. Because a specific group of dinosaurs called theropods are actually the direct ancestors of modern birds. So we're talking about dinosaurs that walked on two legs, had hollow bones, laid eggs, and this is the part that always gets people. Many of them had feathers, which means birds didn't just come after dinosaurs. They're what's left of them. And that's why scientists look at birds when they're studying dinosaurs, because genetically, structurally, and evolutionarily, they're the closest match we have. Now, you might be thinking, okay, but what about reptiles? Because that feels like it should be the obvious answer. And I 100% agree with you. I was shocked when I learned this. Reptiles, like lizards and crocodiles, are related, but they branched off earlier in the evolutionary tree. So they share a distant common ancestor with dinosaurs, but they're not part of that direct lineage. And sea creatures? Yeah, don't worry, I thought about that too. Apparently, that's a completely different story. Marine reptiles like plesiosaurs and mosasaurs, while they look like they belong in the same category, evolved separately. So they're not even technically dinosaurs, which feels like false advertising, but okay. And I think that's what makes this whole thing so fascinating, because when you picture a dinosaur, you're not actually picturing the most accurate version of what they were. You're picturing a very stylized, reptile heavy version that we've all collectively agreed on, when in reality, a lot of them were probably a lot more bird like than we'd like to admit, which just adds another layer to this entire conversation. Because if birds are the closest thing we have to dinosaurs, then when scientists start talking about editing bird DNA to bring back certain traits, that's not as random as it sounds. Still weird, but not random. And honestly, I think that's part of what makes this whole topic feel so surreal, because the line between extinct and still here is a lot blurrier than we tend to think. So now that we've established that dinosaurs didn't completely disappear, let's talk about the part everyone is actually wondering. Could we ever realistically bring them back? Like, for real? All right, so let's just address the question, because I know it's been sitting in the back of your minds this entire time. Could we actually bring dinosaurs back? Like, for real? Short answer, probably not. Longer answer, still probably not. But let's talk about why, because this part is actually really interesting. The biggest issue comes down to one thing: DNA. Like I mentioned earlier, DNA is not built to last forever. Once an organism dies, its DNA immediately starts to break down. And even under the best possible conditions, like freezing, it only lasts for so long before it becomes too fragmented to be useful. And when scientists study this, the general consensus is that usable DNA doesn't really survive beyond about 1 million years, give or take. Dinosaurs went extinct around 65 million years ago. So we are very, very far past the point of being able to recover intact dinosaur DNA, which means the whole Jurassic Park concept, finding, dinosaur DNA in a mosquito trapped in amber, is a great movie idea, but scientifically, not really how it works. Because even if you found a perfectly preserved mosquito, the DNA inside it would still be too degraded after that amount of time. So when it comes to true dinosaurs, we don't have the genetic blueprint. And without that, you can't clone them, you can't recreate them, you can't bring them back in any direct way. Now, that being said, this is where things get a little nuanced because while we can't bring back actual dinosaurs, we can study their closest living relatives, birds, like I said, and start to understand how certain traits evolved. And theoretically, scientists could experiment with reintroducing some of those traits. So things like teeth, longer nails, more primitive, limb structures, like we talked about with the little dino-chicken situation. But at that point, you're not bringing back a dinosaur. You're just creating something else inspired by one. If that makes sense. And I think that distinction matters because there's a big difference between we brought back a T-Rex and we created a modified animal that shares some characteristics with ancient species. One is Jurassic Park, the other is something else entirely, right? And honestly, that, something else might be even harder to predict because at least with a known species, you have some idea of how it behaved. But when you start combining traits, editing DNA, and creating organisms that have never actually existed in this exact form before, you're entering very unknown territory. So, no, we are not about to see a T-Rex walking down the street. Everyone can breathe and relax because I don't want to live in a world where T-Rex is just, on the loose, right? But we are moving toward a world where we can manipulate life in ways that start to blur the line between past and present. And that's where this conversation gets really interesting. Because once you accept that dinosaurs really are not on the table for us because of their, expired DNA, I guess we could call it, you start to focus on what is on the table and what you're choosing to do with it, which brings us to the part where things get a little more complicated. Because now we need to talk about the ethics of all of this without making it feel like a lecture, I promise. All right, so I know ethics is everyone's favorite topic, but don't worry. This is more like the thoughts that start creeping in after a glass or two of wine, and you're just like, wait a minute. Because on one hand, this all sounds incredible. I mean, honestly, the idea that we could bring back species that humans completely wiped out, restore ecosystems, potentially reverse some of the damage we've done, like that's a very compelling argument. It almost feels like redemption. But then on the other hand, there's a little question underneath all of it. Are we fixing something or are we just creating something new and calling it a fix? Because these aren't the same animals. We've already talked about it. They don't have the same environments, the same social structures, or the same evolutionary context. And literally, we're recreating them. They're not reviving them like we talked about, right? So even if the intention is good, the outcome is still unknown. And then there's the animal welfare side of this, which I feel like doesn't get talked about enough because getting to one successful animal doesn't happen on the first try. It can take multiple failed attempts, embryos that don't survive, animals that may not develop properly, and that's just kind of part of the process, which is normal in science. But when you zoom out, it does raise the question of what we're willing to justify in the name of progress. You know what I mean? There's also the, playing God argument, which I feel like always comes up in conversations like this. And I don't even mean that like dramatically. It's just the reality that we're making decisions about, what species exist, what they look like, where they live. And that's a level of control we haven't really had before. And again, that doesn't automatically make it wrong, but it does make it significant because we don't have the best track record for stopping ourselves once we realize something is possible. We usually just keep going. And that's a good thing and a bad thing for humanity. I mean, if we didn't keep going, we probably wouldn't have made it as far as we have, but sometimes we take it a little too far. I think we can all agree on that. But the biggest question for me is this: are we doing this because it's truly necessary or because it's interesting and we can? Because those are very different motivations. and they lead to very different decisions. All right, so let's be honest with ourselves for just a second. If humans figure out how to do something cool, rare, and slightly unhinged, we are definitely going to monetize it immediately, because this whole thing is being framed as science, conservation, ecosystem restoration, all valid, all important. But there is absolutely a version of this future where it becomes a business, and not even in a subtle kind of way. Like, imagine for a second you now have access to animals that haven't existed for thousands of years, look completely different from anything we have today, and are rare, complex, and very expensive to create, like very expensive. You're telling me no one is going to turn that into an experience? And there is no world where that stays purely scientific forever. At some point, someone is going to look at that and go, okay, but what if people could see this and interact with it? You know what I mean? And that's where it starts to feel very familiar, because now we're talking about private reserves, exclusive experiences, high end ecotourism, possibly even controlled safari style environments. And suddenly we're not that far off from the concept of Jurassic Park. Not the chaos, hopefully, but the business model. And to be clear, I'm not saying that's currently the goal. A lot of these companies are very focused on conservation and research. So I don't know. I just think a lot of the initial reasons that we as humans do things is for a noble idea or a reason, or, our intentions are good, basically, is what I'm trying to say. But then once we kind of figure out how to do it or whatever, shit goes off the rails sometimes, and it doesn't end well. Do you know what I mean? So, but historically, once something like this becomes possible, the applications expand, and fast, because there's demand. People would absolutely pay to see a real life version of an extinct animal. Can you imagine standing next to a giant ass woolly mammoth? Like, are you kidding me? I mean, it would be cool. Don't get me wrong. Like, I'm not sitting here, shitting on the whole idea, but I don't know. Um, but then you get into this weird gray area of, is this conservation or is this entertainment with a science label? Because if an animal is being created, contained, and displayed, even if it's for educational purposes, it still starts to blur that line a little. And I think that's the part that makes this feel less hypothetical, because it's not just about what scientists are doing, it's about what happens after they succeed. And I think it also introduces a new layer of risk, because now decisions aren't just being made based on science. They're being influenced by profit, demand, public interest. And those don't always align with what's best for long term. Okay, so this is the part where my brain personally starts to go down a path that maybe I shouldn't follow, but we're going there anyway. Because once you combine advanced genetic editing, animals that haven't existed for thousands of years, and humans just being humans, you have to at least consider what could go wrong. And I don't even mean that in a dramatic way at all. I mean in a very real, very practical sense, right? Because even with animals that exist today, we don't have perfect control, and we shouldn't. Like, we shouldn't have control over, wildlife, right? But there are always variables. Behavior is unpredictable, environments shift, shit happens, right? So now imagine introducing animals that have no modern behavioral reference, are being recreated or modified, and are placed into environments they didn't evolve for. Like, we don't actually know how that's going to play out. And I think that's the part that gets glossed over a little bit, because it's easy to focus on the science, the innovation, the, wow factor. But unpredictability doesn't just go away because something is well funded or well researched. And then my brain goes one step further, as it does, right? The world, it's already chaotic enough. Can you imagine throwing, a T-Rex or any crazy animal into the mix? Like, my God, we already have enough problems. Like, we can barely handle traffic, weather, the economy, my God, literally just daily life. And now we're talking about introducing apex predators hypothetically into the same world. And again, I know we're not actually bringing back T-Rex. Like that would be a huge problem. Let's all stay grounded. But even on a smaller scale, even with animals that are realistic for de-extinction, there's still a risk. Like, what happens if the behavior doesn't match our expectations? What happens if something adapts too well? What happens if it disrupts something we didn't anticipate? Because history has shown us over and over again when humans introduce species into environments where they don't naturally belong, it doesn't always go smoothly. And I think that's what makes this different is that it's not accidental, it's intentional. We are choosing to do this. And I don't know. There's just something about that it feels like we're stepping into territory where we don't fully know the rules yet. And not in like a fear-mongering way, just in a very honest, very human-like way, like we're experimenting at yes, we're experimenting, but it's at a scale that affects real ecosystems. And I don't know. And maybe everything works out. Maybe it's controlled, regulated, beneficial. Who knows? But I'm not a scientist, I'll tell you that much. But also, I mean, maybe it's more complicated than we expect. And I don't know. We're not, it's not like this is doomed. It's just more like we should probably respect the fact that we're dealing with something inherently unpredictable, because once something like this is out in the world, you don't really get a redo. So, yeah, after all of that, I think for me, it's one of those situations where I feel two completely opposite things at the same time. Because on one hand, I'm totally fascinated by it, like the science alone is incredible. The fact that we've gotten to a point where we can edit DNA, I mean, that's just bananas. At recreate traits and even attempt something like de-extinction. That's objectively impressive. It's innovative, advanced, and totally mind-blowing. I mean, agree with me, please. It really is. But at the same time, there's this underlying feeling of like, just because we can do something does not automatically mean that we should be doing it. Because honestly, if history has shown us anything, it's that us as humans, the good intentions that we may have, we're really good at pushing boundaries and not always great at knowing when to stop. And I don't know. I don't think this is about fear. I don't think this is about, this is going to go horribly wrong. I think it's more about awareness, like understanding that we're stepping into something new, something complex, something that doesn't have a clear roadmap yet, that's for sure. And maybe we need to just move a little bit more thoughtfully, cautiously, intentionally, because this is not just an experiment in a lab. This is something that could affect real ecosystems, real people, real animals, and the world that we actually live in. So I don't think it's a terrible idea. I just think that it's a powerful idea, and powerful ideas deserve a little bit more respect than I think we tend to give them. So now I want to know what you think, because honestly, this is one of those topics where I feel like everyone lands a little differently depending on what part stood out to them the most. So if we can bring extinct species back, should we? Would you visit a real life reserve or park with de-extinct animals? Should we only bring back animals that humans caused to go extinct? And if dinosaurs were possible, would you actually want that? All right, well, that's it for today, but thank you so, so much for hanging out with me. Before you go, if you're not subscribed to the After Hours newsletter, you are missing out. Every Friday, you'll get a quick episode recap, the quote of the week, a confession from a fellow listener, my personal takeaway from the episode, and of course, the wine behind it all. Speaking of confessions, if you've got one, we want to hear it. It could be a conspiracy you low-key believe, an embarrassing story, or a hot take about literally anything. Whatever it is, we want it, so submit away. You can also pitch episode ideas. So if you've got something you want us to talk about, we are all ears. You can do all of these wonderful things by visiting our website at winenotpod.com. And if you love the show, leave us a review. It really does help more than you think. All right, well, thank you again so much for joining me, and I will see you next week for another wild ride. Bye.